Okay, so what we're looking at here on the generator is the wiring configuration that ships with the generator, which is series star. So everything is wired up on the terminal blocks as series star. And what we're going to show today is how to install the paralleling device from McCalty and how to connect that up and do some testing on it. Okay, so the paralleling device, one of the things about it is we are going to pass current through this thick gauge wire between these two terminals, and we need to get that current or the connections connected to one of the main legs on the generator. So the way we're going to do that is we're going to use these terminals on the genhead to connect to these ring terminals, and we need to modify things slightly. So we're going to actually use the two terminals on the rightmost side. Those are not actually connected in any way to the generator. And we're going to use this to create our connection. So I'm going to disconnect these, remove the washers, and basically take all of these terminals off here. And I'm going to remove all of these bus bars, these brass bus bars, from this. And I'm going to use a zip tie to tie them together and not lose them. I'd recommend tying them to the equipment itself, but in a place that is not going to end up shorting anything out. So I'm going to tie them down here. Might be best to put them in a Ziploc bag or insulate them with some tape, just to avoid that risk, but we're going to tie them down there. Okay, so now I'm going to move all of these terminals that were on the topmost block and install these on the lower block, like so. And I'm not going to tighten them down since this is just for demonstration. Okay, and now I'm going to remove the nut for terminal U2. I'm going to take that, remove both of these. So we're going to keep wire number 3 from the genhead on this terminal. And then we're going to take our one of our terminals here. One of the things that's important on the transformer is, like we experience on the deep sea current transformers, the polarity of them is important. And so I'm wanting to keep the geometry of this consistent. And so in this case, we are going to connect from the wire that is going in to the terminal, or into the coil, with the wires facing to the left side. So I'm going to take this wire and put it on the terminal that is connected or has generator wire number 3 on it. So we are going to connect that, tighten that down. Now this wire coming out of the current transformer is going to go onto terminal N2 of the generator. And then the terminal, or the wire number 2 from the genhead, is going to come onto this post. So now we're going to have current flow through one of the coils on the generator before it goes into the rest of the series star configuration. Okay, so now we have the wiring to allow the current flow set up on the generator. The other part that we need to connect are the wires that come out of the generator, or out of the current transformer, and these are used to create a biased input signal to the AVR. So this is the McCalté DSR AVR, and there's typically this green wire which is always connected to terminal 6 on any of our setups. So we're going to take that and remove it. And now the terminals on this have been set up so that it's pretty easy to avoid confusion. But we're going to connect the yellow wire with the male terminal blade onto this green wire. And now we're going to connect this red wire onto the blade for terminal 6 on the DSR. And now this voltage that will come out as current flows through this transformer will help to bias the signal and help to dampen the effect as reactive power is flowing through the generator. So that's basically the wiring for this. And one last thing that I would recommend is that it's possible to, as I said before, the polarity of current transformers is critical. If they are wired incorrectly, since we're trying to dampen the reactive power, if the polarity is flipped, you could end up with getting a very rapid increase in current flow. And we've seen when this is flipped around and we try to do load sharing, we get a near immediate short circuit alarm on the deep sea. So we want to avoid that and want to make sure that every generator is connected correctly. So the way that you can test that is that you connect this little terminal to leg 2 from the generator. That is terminal V1 on this terminal block. And we're going to plug the outputs from the current transformer into this. So in order to test the polarity of this current transformer, what you should do is connect the wires up, disconnect the output from, disconnect the current transformer from terminal 6 on the DSR and reconnect the green wire to terminal 6. And then take the current transformers and plug the female terminal into the male terminal of that is connected to leg 2 on the generator. And then be very careful, since this output is going to have high voltage on it, so this should be kept, say, in some way that it's not going to touch anything, or you're not going to touch it. So take a voltmeter, preferably with some alligator clips, connect it to this terminal, and then measure the voltage between this and your neutral on the generator, which is going to be connected to N2 here. Now measure that, and if you apply at least a few kW of resistive load to the generator, you should see the voltage here decrease. If it does the opposite and increases, then the polarity of this current transformer is incorrect. And the way you can fix that is just reverse the wires that are going between here and here, flip those around, and now your polarity should be the correct orientation. And you'll want to make sure that every generator has been tested in that way to make sure that they are all behaving in the same way and in the correct way, which is that you want the voltage to decrease as resistive load goes onto the system. So also to note, in this case, we can pretty well check for the way the current transformer is wired, because we can see how the coil is wrapped around. So you can also double check that just the geometry of the current transformer is at least consistent. Make it consistent across everything. If you get an immediate high current behavior, then things are flipped around the wrong way. Reverse everything into the other orientation, and you should be good to go. One other thing is that this is current transformer is a little bulky. There's not a particularly great spot to install it anywhere onto the metal of the genhead. So my recommendation would be to take this current transformer and use a zip tie and basically tie it around the bundle of wires coming out of the genhead here in such a way that we don't get any short circuiting or contact with anything or any risk of that. But yeah, basically get that tied in here and very tight, and you should be good to go. Also, the blue and green wires serve no real purpose, so you can tie those and tuck those away. Keep them spare in case we need them later. Okay, so that's it.